Let us start. Good morning. In the previous session, we already started various kinds of systems. In this series, 5 systems already over. Now, the 6th kind of system, now just we are going to discuss. Let us start. Now, here, there is another kind of systems. These are called lumped parameter systems and distributed parameter systems. Lumped parameter systems, distributed parameter systems. Now, just we have to have a clear-cut distinction between these two kinds of systems. These systems are one of the family of group of systems. Now, let us start with. So, under this concept, now just take the systems. Now, under this heading, just we are making 2 different kinds, sub-kinds. One is called lumped. One is called lumped parameter. The second kind of system is called distributed parameter. Lumped parameter, the second one is called distributed parameter systems. Whether these are lumped or distributed, whatever it may be, but the main concept of these systems are location based. Very important. Students have to notice this. These, whether it is lumped parameter system or distributed parameter system, these two are based upon location based system. So these names are assigned because of the location. That's why just here we are mentioning that these two classifications of systems come under the category of locations, only locations. Now these kind of systems, now we are going to discuss. Students have to note the important points in this discussion. Let us start. Here, no need to have any mathematical equations or system modeling to get proved the given systems. Here, the distinctions we have to make between these two systems. So this concept is to make distinctions between these two kinds of systems. So no mathematical modelings are expected in this context. Okay? Now, let us. So this is what lumped parameter systems. This is distributed parameter system. Now just look at lumped parameter system, distributed parameter system. Whatever the system, whether it is lumped or distributed, whatever it may be, it is based upon location. Based upon location. Now just look at. Just make the distinguishing, we are going to make distinguishing between these two, lumped and distributed. Now let us start. In electronics and electrical, some parameters, that means what? Parameters means, for example, just look at inductance, resistance, conductance. These kind of inductance, resistance, conductance, all these will be considered as parameters. Here parameters means what? Inductance, resistance, conductance, reactivity, reactance, all these will be taken as parameters. Here also, so whether it is LPS or DPS, we are making these as a fundamental basic discussion point. Now, inductance, resistance, conductance, etc., all these will be considered as parameters. But at the same time, these are all concentrating. These are all concentrated at a single point or single domain. That means location is a single point or a single domain. Location is a single point or a single domain. Just look at all these are grouped. All these are grouped in the single location. that means what? Grouping together. That is called, in English we call it as lumped. Lumped. So lumped means what? Grouping together at a single domain or a single point. That's why the name is assigned to this kind of concept, that is called lumped parameter system. Here parameter means what? Inductance, resistance, conductance. Understanding? Now just look at, come this side. The same parameters, inductance, resistance and conductance, the same parameters are located at different locations. These are located at different locations. Different locations. That means what? These parameters are not be at a single point, a single location. These parameters are distributed, randomly distributed. That means what? So many number of locations. They may concentrate on different types of locations. Here just look at, here only single domain, single location. Here different locations. Different locations means what? All these parameters are distributed. That's why the name is assigned as distributed parameter systems. Students have to analyze each and every point, every word of the definition very carefully. Understanding? Again just look at, here LPS and DPS. PS is common. PS is common means what? Parameters. That means these systems are based upon some parameters. What are these parameters? Inductance, resistance, conductivity, reactivity. All these come under the concepts of parameters. Understanding? So all these parameters are located at a single location or single domain. So now these are called lumped parameter systems. Now here we call it as distributed parameter systems. So all are distributed. One more point. So because of the single location, all will be taken as a single variable. All will be taken as a single variable. All will be taken as a single, what kind of variable? Single independent variable. All will be considered as a single. All these will be considered in a group. There will be no separate distinction of resistance, separate distinctions of conductance, separate distinctions of inductance, like that. All will be considered and taken into a single location, single variable, independent variable. But here all will be considered as different individual, that means different independent variables. Look at, this is very much important. Here all will be considered as a single independent variable. Here all, each and everything will be considered as an independent variable. So it contains only one independent variable. It contains more than two or more than two independent variables because of its nature of distributivity. But this is the nature of concentrating at a single point, that is called lumped. So here only all will be considered as a single independent variable. Here all will be considered as different independent variables. So now because of this reason, we use differential equations here, that is dy by dx. So for this purpose we use differential equations. For example, dy by dx like this. Because of this nature, because it contains so many number of independent variables, so here we use partial differential equations. So here we make it partial differential equations. For example, dou y by dou x. Here y is a function of two or more than two independent variables. Here y is a function of one and only one independent variable. That means what? For example, y is a function of x of t, x only. But here y is a function of x of t or etc. etc. That is the nature of this one. Now here in the simple circuits we are going to get LPS, but look at our electric transmission lines, very big transforms, etc. etc. For all those kinds of transmission lines, telephone cable lines, cable wires, for all these one you are going to get distributed parameter systems. In the practical reality, just we are going to get distributed parameter systems. So electrical transmission lines and the telephone cable wires, all these comes under the category of distributed parameter systems. Now this is another distinction. Now here between the lumped or distributed, whatever it may be, but all these will be considered as only parameters. We already discussed that point. Another point is that efficiency basis. Regarding the efficiency is concerned, these are concentrated at a particular location only. On the particular location, what is the impact of inductance, what is the impact of voltage, what is the impact of resistance, what is the impact of conductance, you can't measure perfectly because all will be taken as a single independent variable. So which influence is more, you can't imagine. That's why the output of this lumped parameter system is not efficient. You can't 100% depend upon its result. But here, just look at here, each and every parameter, inductance separately taken as independent variable, resistance separate, conductance separate, each and everything will be taken as independent variables. That means the impact of each parameter will be exactly measured. That's why for more practical applications, we always depend upon distributed parameter systems only. This point is very much important. So in practical reality, we use distributed parameter systems. Only in the specific cases only, we used to have LPS. But for more practical use, we always depend upon this distributed parameter systems only. But one more point, regarding the cost efficiency, these are distributed in the single location, therefore cost may be less. But measuring these, taking all, cost will be more because all will be distributed at different locations. But efficiency basis, this is efficient. This is not that much efficient. Understanding durability for everything, we are making distributed parameter systems taking into consideration. This is very much important. So now in the single shell, I will give you the importance of this one. Here these systems, they do not contain any mathematical proofs or any mathematical requirements. Now again, just look at lumped parameter systems. First you can make it. So here we will get systems under this category. This is lumped parameters. So this is lumped parameters. This is distributed parameter systems. Now, lumped parameter system based on only single location. It is based upon different locations. So here all parameters will be considered. All parameters will be considered as a single independent variable. But here each one will be considered as an independent variable. So because of this purpose, we use ordinary differential equations with constant coefficients. Now, here we use partial differential equations. Understanding, these are less efficient. Now here, these are more efficient. Here, cost is less. Cost effective. Cost is less. Don't write cost is less. You have to write cost effective. Here, more cost. Here it has more cost. So here, for less practical applications, it has very few practical applications. It has more practical applications. In the real life, we use only little bit on small circuits. Here we get these lumped parameter systems on small circuits only, in the small circuits only. But here we use electrical transmission lines and telephone cable wires etc. We use all these distributed parameter systems. So the differences just we have to make it. So this topic ends. The differentiation between lumped parameter systems and distributed parameter systems. So only one point, parameters means inductance, resistance, conductance, all these things will be the parameters. So make the difference clear cut. Thank you.